Hello everyone. So today we are discussing about the concept of function. Function is a very important concept for the mathematical point of view. This is dominant mainly in calculus and basic algebra. So how to define the function? Actually function is a machine. Function is a machine, but we define the function the point of view of relation. So a function is a special type of relation. If a relation is defined from A to B, then a relation will become function if all the element of set A having unique image in set. Like if a relation R is defined from set A to B, then the function can be written as like function f such that A to B. The element of f set A is associated with element of set B in any way is called a relation. But when all the element of set A is associated with element of with B uniquely, or we can define as all the element of set A having image in set B, then that is called a function. Like example, the set A is given as having element 1, 2, 3 and set B having the element like 2, 3, 4, 5 and 6. This can be visually we represent like set A having element 1, 2, 3 and set B having the element 2, 3, 4, 5, 6. So if first condition is what? A relation to become a function, the first condition is all the element of set A. All the element of set A having image. In set A, none of the element will be blank. All the element having the arrow, that is all the element having image. This will be associated with element B, that is 1 have the image 2. This element is associated with C, that is 2 having the image 3. This element is associated with 4, that is 3 having the image is in 4. So 2, 3 and 4 are the image of element of set A. That is called the image points. Like 2, 3 and 4 are called the image points. 2, 3, 4 are called the image points. And the element for which this element are the image, they are called the pre-images. So this is called the pre-images, set of pre-images like 1, 2, 3 and this is called the set of images like 2, 3, 4. So this is function. Why? Because all the element of set A having image and that image is unique. Unique image means what? Unique image means one element having only one image. If one element having more than one image, then that will not become the function. That will relation, but not will become the function, because the condition is that only one element having one image. So one element having image 2, 2 is 3 and 3 is 4. So they are uniquely associated, that's why it is called function. So function is defined as, in this scenario we can write the function like 1, 2, 2, 3 and 3, 4. So this is called the function. The special thing in the function is what? If the function f is defined from A to B, then the first element of ordered pair within the function belongs to the set A, and the second element of ordered pair within the function belongs to the second set B. Like 1, 2 and 3 belongs to set A and 2, 3, 4 belongs to set B. Yes, these ordered pair element in general written as like x, y. So this form is called the what? This form is called the roster form of function. This roster form can be written in the definition form, that is called the side-welder form. So side-welder form can be written as like all the element written in the form of x, y. So the representative of these elements like x, y. So how they relate? The first element, that is x. First element x can be 1, 2 and 3 and y can be 2, 3, 4. So x and y, how they relate each other? Like 1, 2, the difference between them is 1. 2, 3, the difference between them is 1, and 3, 4, the difference between them is 1. So y minus x is equal to 1. That can also be written as y is equal to x plus 1, such that x is always belongs to the first set and y is always belongs to the second set. So this is written in the form of set builder form or definition form. So function is behave like a machine. How the machine works? How the machine works? If there is a machine, then we apply some types of inputs and get the outputs. Like example, air conditioner. If we apply the power, then the machine works. It starts cooling and the room will be cooled. So giving the power is called the input and the machine is working, that is called the processing of function, and give the output that is called the image. So the output is called the images and applied inputs are called the pre-images, and this is the processing of function. But this function is only works when all the element of set A having image in set B. Okay, so function is defined as from set A to set B, that all the element of set A having image and that image is unique. All the element of set A having image in set B and that image is unique. This is the proper definition of functions. Okay, that's all about the functions. Next one is called the, so here I give some examples of function. This is the first example of function in which all the element of set A having unique image in set B, and the next example we can see the element of set A is 1, 2, 3 and set B having the element 2, 3, 4, 5, 6. The one element is associated with 2 and 2 element is this a function? No, this is not a function. Why? Because in set A the 3 element having no image, but the condition of function is, the first condition is function is all the element of image, but 3 is having no image. That's why this example will not represent the function. So 3 has no image in set B, hence the above mapping is not represent the function. We take another example like set A having 1, 2, 3 element, and this is the element of set B, distribution of element of set A in B. So in this mapping, is this a function? We can check the first element having one only single image, the second element is also having the single image, and third element is also the single image. Third element is also, if only one arrow can be drawn from one element, that is represent the single image. So this is one arrow and one arrow, that will represent the single image. Single image means unique image. So that image unique and all the element of set A associated, that means all the element of A having image. So all the element, so both condition is satisfied in this example, because all the element of set A having image and that image only one arrow is drawn, that is single image. Okay, so more than 2 element can be have the same image, that is called the many-one function. When we learn about the classification of function, when more than 2 element having only single image, that is called a many-one function. But this is a function because all the element of A having image and that image is unique. So this is called a function. We take another example like 1, 2, 3 is the set element of set A and so on. So we see all the element of having A having image, one element having image, 2 element having image, 3 element, all the first condition is satisfied, but the second condition is that image is unique. So only one arrow is drawn, that is single image, only one arrow is drawn, that is single, but element of 2 having 2 image, more than one image, 3 is the image of 2 and 4 is the image of 2. So 2 element having more than one image, that's why it is not a function. When any element of set A having more than one image, that is called not a function, because that element have not the unique image. Okay, so that's why 2 does not having the unique image, hence above mapping will not represent the function, it is not a function. Okay, so as we know, the function is the machine in which we apply the x element which belongs to the set A, and after processing of function we get the output, that is y, which is associated with the set B. Okay, so So that's all about the function definition. So we have to idea about all those examples and all those category of examples. Okay. So next I will represent the graphical representation and how the graphically we check the given expression is a function or not, or given graph is a function or not. So that is also called the vertical line test. If the graph of function is given and we have to check that is function or not, so we draw a vertical line. If we draw the vertical line in the function or graph, if vertical line intersect at only one point, if vertical line that is parallel to y-axis intersect the graph at only one point, then it is called a function. That intersection at only one point will represent the unique image. But if the vertical line intersect the graph more than one image, that is not a function. Why? Because the intersection, more than one intersection point will represent the more than any one element having more than one image. That will not the unique image. That's why they are not the function. So in given graphs, like this is first graph, second graph, third, fourth, fifth, sixth and seventh, we draw a vertical line and check the given expression is a function or not. So the first graph is, this is the expression of x square equal to y. We draw the vertical line and we get the single intersection, that's why it is a function. If we draw the graph of this expression is x equal to y square, that is also a parabola, and this is also a parabolic equation. So if we draw vertical line and this intersect more than one point, that is not a function, because this will represent four element having the two image. The first one is 2 and second one is -2. So that is not a function. The next function is the next graph is like this, and we draw the vertical line, it intersect at only one point, that's why it is called function. Next graph, if we draw vertical line, this intersect more than one point, not a function. In this graph, draw vertical line, intersect at only one point, yes, it is a function. If we draw vertical line, it intersect the graph at only one point, yes, it is a function. If we draw vertical line, it intersect the graph at only one point, so this is a function. So using the vertical line test, graphically test, this is also called the graphical test. So using in graph point of view, if we draw vertical line, it intersect at only one point, that is function. If intersect the graph more than one point, then it is not a function. So we have to idea about this. Next is called the domain of function. Very important things. Domain of function is very important for board point of view, JEE point of view. That section is very important. So first one is called the domain of function. What is domain of function? If function f is defined from set A to B, then the value of a, value of x which belongs to set A, for which having the unique image, the function is called the domain of function. The function is defined from A to B, then all the element of set A, all the set of x which belongs to set A is called the domain of function. That can also be defined in different way. A value of x input for which function is defined, value of x for which function is defined, those set of values of x are called domain of function. Next one is range of function. Range of function, if function f defined from A to B, then all values of y which belongs to B is called range of function. That can also be defined in different way. Sorry, like value of y for which function is defined is called range of function. Next one that can also be defined as the image point of domain is called the range of function. Next one is called the codomain of function. If function defined from set A to B, like relation, codomain of relation, the codomain of function is also treated as the same. The complete set B is called the codomain of function. So if any function is defined from like A to B, so the set A, this is a function, the complete set A is called the domain of function, the image point in set B is called range of function, and complete set B is called the codomain function. So we have to idea about this. So set of pre-images, they are the pre-images, set of pre-images is domain, they are the 2, 3, 4 are the images, 2, 3 and 4. 5, 6 are the not image. So 2, 3, 4 are the image. So set of images is called range, and the complete set V is called the codomain of functions. Okay. So that's all. This is very important section. When we apply this concept in the some different types of example, special examples, then this is very important. Okay. So these are the some examples, simple examples. Okay. So we can avoid this. Next one is called the real function. What is real function? So a function is called a real function if domain and range or codomain is a subset of real number. If set is defined from A to B, then set A is the subset of real number as well as set B is also the subset of real number. That is called the real function. In class 12th, 11th or in JEE point of view, we only deal with the real functions. All the domain or codomain of the function is always a real. Okay. So we only deal with the real functions. Okay. Next, this is also the examples, that is called the, well, we can also define value of function. This we learn in class 9th. This we can learn in class 9th. Value of function. Value of function is a very silly things. Okay? Very small things. Value of function is defined as the value of fx. If function is written as like y is equal to fx, then value of fx or value of y, when we put for the particular value of x like alpha. So at x equal to alpha, what is the value of function? That will become f of alpha. So we just put the value of x in the given expression in place of x, and we get the value of function. So this is defined as the value of x at any value of x, which is value of fx at any value of x, that is input for which belongs to the set A, and we get the value of y, and which always belongs to the set V if the function is defined from A to B. So this is just simple things. Like we can take the example like function defined from R to R and given by fx equal to this expression, and we have to find f of 0, value of f of 0, value of f of 1. So just we put the value of x equal to 0 in this expression, and we get the value of f of 0, that is value of function at x equal to 0. Next one, f of 1, we just put the x equal to 1 in this expression, and we get the value of f of 1 like 9. So 3 into 1 3, 5 into 1 5, plus 1 3 plus 5 8 plus 1 9. So thus just we get the value of function at x equal to 1, that is f of 1 like 9. So this is very simple things, don't worry. Okay. Next, this is very important, very important. These things are very important for JEE point of view also, not only boards. This is very important for JEE. Okay. Okay. Next, domain of function. We already learned about the domain of function, but we define the values of x. X values are called domain. Values of x for which function is defined are called domain of function. So we learn the different types of function, and we deal with there is no direct formula of domain of functions. There is no formula. This is only pure conceptual things. They are conceptual things, and we have to learn. We have to learn with the exercises. Okay. So this is the first function. If function is defined like under root of expression, any expression is given within the under root, then how to find the domain of this type of function? This function is only defined, we know any function is only defined the under root value when within under root we put only the positive or the non-negative value. So when this expression like fx is always non-negative, that is greater than equal to 0, either 0 or positive, then this function is defined. So we apply this condition and find the value of x. The set of this x is called the domain of function. Next one, if gx is defined as like constant upon fx or fx upon gx, anything rational function, then we know that the denominator value cannot never be equal to 0. In rational number we learn the rational number comes in the form of p upon q, and q never be equal to 0. So that's why fx never be equal to 0. So whenever we get the rational function, then we apply the denominator condition, that will never be equal to 0, and after applying this condition we find the value of x, and after applying this condition from this condition we find value of x, and these values of x are called domain of function. Next one is called a constant upon under root fx. So when in denominator root fx expression is given, then that can never be equal to 0. Why? Because this is in denominator, and because of root it is always be the non-negative, that is greater than 0. So that can never be 0. Why? Because in denominator, and this will be always positive value. So fx is always positive. So after applying, if we get this type of expression, we apply this condition like fx is always greater than 0. Why we apply this condition? You know, I already explained it. So we apply this condition and get the value of x, and these values of x are called the domain of the given function. Like next type is log fx. Logarithmic function is only valid when the operated value is always positive value. Operated value is always positive. If the operated value is negative, then log will become undefined. Log is a function which is only valid when the applied value is positive. So if this type of expression is given, then we apply the condition this value is always positive, and we calculate the value of x, and this value of x or set of value of x is called the domain of the given expression. Next one is log fx base hx. If operated value and base value both are in variables, then two conditions are there. First condition is operated value is always positive, and the second condition is the base value is always positive as well as never be equal to 1. Why? Because in base change theorem it will become in denominator, and when denominator value will become log 1 and log 1 is 0, then denominator is 0, and when the denominator is 0, the function will become undefined. That's why hx never be equal to 1 also. It is always positive as well as never be equal to 1, and operated value is always 0. After taking the intersection of both condition, we get the final domain of the given expression. So we can find this type of expression, we can find the domain of this type of expression. All conditions are very important, all expression are very important for board point of view as well as JEE point of view. In JEE maximum questions are created, okay? more than many questions are created on this type of expression. So if we take two functions, like two function fx and gx, they are they are connected, like they are added, subtracted, multiplied, then we individually find the domain of first function as well as second function, and we take the intersection of both, that will define the domain of the complete expression. If they are in division, then we find the individual domain of the numerator as well as denominator function, we take intersection. But we know that the in denominator this can never be equal to 0, so we avoid those values of x for which denominator becomes 0, that is g becomes 0. Those values of x can be rejected from the intersections room. So this is the point of view of domain that can be very important. Okay, so we take some examples like 5 upon x minus 3. So we know that the denominator can never be 0, so x minus 3 never be equal to 0, x never be 3. So this function is only valid, this function is valid for all values of x but can never be equal to 3. So x belongs to minus infinity to plus infinity but never be equal to 3. So reject the value of 3. Next example is find the domain of 2025 divided by x square plus 5x plus 10. So denominator can never be 0 because this is also that rational function, so this can never be 0, but we get the value, we factorize this expression and get the two values of x equal to minus 5 and minus 2. So for defining this function, x can never be minus 5 and minus 2, but can be anything. So domain of function is defined as all real value, capital R is the representation for real value except minus 5 and minus 2. Next expression is defined as the domain of x minus 2 upon x square minus 4. So the condition is we can make a mistake in this question. Why? If we take the example like x minus 2 divided by, if we factorize this, then x minus 2 divided by x plus 2, because this is the expression of a square minus b square, x minus 2 is cancelled out, and we can write the x plus 2 can never be 0, x plus 2 can never be 0. So we can say what? We can say x can be any real number except minus 2, but this concept is wrong. Why? Because we cancel out the x minus 2 and x minus 2. they are not, we cannot cancel out this in the domain point of view when the function is given, because in domain this can be 0 at x equal to 2 and we only reject the value x equal to minus 2. So we have to reject the complete expression never be equal to 0. So never equal to 0, that means there are 2 points, not 1 point. We cancel out 1 point, that is wrong. So we have to take both point 2 and minus 2, that will be rejected from this. Next example is fx is given as under root 2x minus 1. We can say we can already seems like under root fx is only valid when the root function, under root function is always non-negative value, that is this function is only valid when 2x minus 1 is always greater than equal to 0. We can find the value of x, like minus 1 will become plus 1 from right side and 2 is divided, so x is always greater than, sign of inequality will remain same. Why? Because 2 is a positive number and in inequality when we divide the positive number the sign of inequality will remain same. So x is always greater than equal to 1 by 2. So 1 by 2 is there, that can be equal to 1 by 2 or greater. Greater means right side region. So this region can be written as the x is belongs from 1 by 2 close to, close why? Because this equality is hold, that's why close interval and goes up to the infinity. The next question is domain of under root x square plus 5x plus 3. On the same way we can factorize, this is only, this function is only valid when the under root quantity is greater than equal to 0. After factorizing this we can find the two critical point. The first critical point y x equal to minus 2 and x equal to minus 3. We plot these point on the real number line, like minus 3 is come first, next one is minus 3, minus 2. From the baby curve we know this region is always positive, rightmost region is always positive, and minus 2 is comes from this factor and the power of this factor is odd, and when the power is odd the sign will be changed, that will become plus 2 minus, and then we go from critical to critical point minus 3 and minus 3 comes from this factor and the power of this factor is also odd, then the sign will be interchanged. If the power is even then the same sign will propagate it, but the power is odd when then sign will be changed. So the sign will change from negative to positive, and the region, what region we require, what region is required, the expression is always positive. This region is positive, so we shaded this region. The equality is hold, that means critical point is also include. The region can be written, the value of x can have the minus infinity say minus 3 close union to minus 2 close say infinity. So in this way we can find the domain of question. These questions are important. This can be different function to function, okay? But this is very important. So these type of function can be important. Okay, so that's all from today. The domain concept is very important from function point of view and the complete calculus point of view, because in limits, in continuity, differentiability, integration, differentiation, anything, application of derivative, differential equation, everywhere function is very important. So and domain is also very important. So this concept should be very strong. Thank you so much.